Hi guys, here's our math problem for today. This is taken from the 2018 American Math Contest for middle school students. Here's the problem. How many perfect cubes lie between 2 to the 8 plus 1 and 2 to the 18 plus 1 inclusive? You can pause the video and check if you can answer this question. Now let's solve this problem together. What we want to find is the number of perfect cubes that lie between this lower boundary up to this upper boundary inclusive. So let's begin with the lower boundary. A quick calculation would show that 2 to the 8 is equal to 256 and we copy plus 1. And so this is equal to 257. Now let's look at what are the perfect cubes that are close to 257. Notice that 6 to the third is equal to 216 and 7 to the third is equal to 343. So clearly 257 is between 216 and 343. And so we now say that 6 cube is less than 257, which is also less than 7 cube. We are particularly interested with this 7 cube because this is the nearest perfect cube that is slightly greater than 257, which is our lower boundary. Now let's put this aside. We are going to go back to this later on. Let's look at the upper boundary, 2 to the 18 plus 1. This 2 to the 18 can also be written as the quantity 2 to the 6th raised to the third. The reason is the converse of the power law of exponent. Now 2 to the 6th can be evaluated as 64. We copy exponent 3 and we add 1. This is already in cubic form, which is what we want to find in this problem. Now let's go back to our previous result. Let's concentrate on this inequality, 257, which is equal to 2 to the 8 plus 1, that is less than 7 to the third. And then in here, 2 to the 18 plus 1 is equal to 64 cube plus 1. If we remove this plus 1, then 64 cube must be a little lower than 2 to the 18 plus 1. But if you take 65 to the third, that is already greater than 2 to the 18 plus 1. So these are exactly the numbers that we are interested in. These are perfect cubes that lie between 2 to the 8 plus 1 and 2 to the 18th plus 1. So our task now, therefore, is just to count how many of these perfect cubes are there all in all. So we can just expand this and inspect all those perfect cubes between these two boundaries. And the faster way to count the number of perfect cubes in between these two boundaries is just to subtract 64 minus 7. But we need to add 1. Why is that so? Notice that if I want to count the number of numbers between 1 and 2, there are 2 of them, 1 and 2. But if I subtract, 2 minus 1 is only 1. Clearly, we are not counting it correctly. We have to add 1 more so that we can get the exact number of numbers between 1 and 2. That is the reason why we also have to add this 1, because we are undercounting when we just subtract 64 minus 7. Because when we count, we start with 1. So adding and subtracting now from left to right, we have 64 minus 7 plus 1 equals 58. There are a total of 58 perfect cubes in between 2 to the 8 plus 1 and 2 to the 18 plus 1 inclusive. And this problem is now solved. Thank you very much. This is Asisten, and we hope to see you again in our next video. Bye for now.